Welcome to this eLearn Security video training lesson on Android network analysis. In this video, we're going to see how to configure an Android virtual device in order to sniff and intercept all the traffic that it generates. As we will see during the video, by default, it is not possible to intercept any SSL-based traffic generated by any applications. But with some specific configurations, we will be able to proxy all the traffic to our machine. There are a few ways that we can sniff the device traffic. We can start the emulator from the command line and set the option TCP dump, or we can run the emulated device and then start a packet analyzer tool like Wireshark and sniff the whole traffic. Let's start with using the TCP dump option. Let's open a new terminal and write the command to start a new emulated device. Emulator minus AVD, capital A, capital D, EV. Where ADEV is the name of the device, then let's scale the emulator window with the command minus scale 0.4. Now we can set the minus TCP dump option to tell the emulator to intercept the traffic and store it in the file named emulator_traffic.cap. Let's execute the command and wait until the device starts. The emulator runs as normal and we can start interacting with it. Since we are trying to sniff the traffic, let's open the web browser. The home page is www.elearnsecurity.com. As we can see in the top bar, the traffic goes through HTTP, so it should not be encrypted. Let's now try to navigate to www.google.com. Note that we are forcing the device to use HTTP instead of HTTPS. Let's now change the HTTP to HTTPS and navigate again to google.com. Of course, it still works, and all the traffic goes through HTTPS. Let's try to search eLearn Security. As we can see, the browser works perfectly. For now, we are done, so we can close the browser and the device and stop the command in the console. If we go into the folder where we started the command, we can see that the file emulator_traffic.cap has been created. In order to inspect this file, we need Wireshark. Let's double click it and let Wireshark open the file. Here we can see all the traffic that has been intercepted from the device. Let's filter it for HTTP, and then right-click on the HTTP traffic and select Follow in Stream. Here we can see the traffic that we have generated while browsing elearnsecurity.com. We are able to see the clear text because we browsed the website without HTTPS. If we change the TCP stream value, we can see all the requests and the responses for each resource of the website. Let's close this view and let's clear the filters field. If we scroll down, we can see that at a certain point, the protocol value changed from TCP to TLS-V1. This happens because while browsing, we changed the protocol from HTTP to HTTPS, and now the traffic is completely encrypted. If we select Follow TCP Stream, we don't see the plain text information anymore. So with the TCP dump option, we are able to sniff and store the whole device traffic. But as we have seen, when the communication is encrypted, we are not able to get the clear text. This is something that happens with applications too, and since we would like to inspect the plain text of the traffic, we have to find a way to bypass this restriction. Before we do this, let's start a new virtual device from the AVD Manager and see how to use Wireshark to sniff the traffic on the fly. Since virtual devices share the host network, configuring our machine to sniff the traffic is very easy. We just need to run Wireshark and configure it to sniff the traffic that goes through our primary network interface. So let's start Wireshark and see how to configure it. In our machine, we have only one network interface, so we can be sure that all the traffic passes through this NIC. Let's select it and start our traffic sniffing. Note that with this configuration, during our interception, we will sniff the host machine traffic too, so we need to be careful when we analyze the data. Now that both the device and Wireshark are running, let's start the web browser application on the device. As we can see, as soon as the browser loads the page, Wireshark intercepts the traffic. The sniffing works in the same way as we saw before, but this time we are able to intercept, analyze, and filter the data on the fly. Let's inspect the communications by selecting Follow TCP Stream. Here once again, we can see all the requests and responses generated for the website www.elearnsecurity.com. So let's clear it and see what happens when we try to browse https://www.google.com. We can see that once again Wireshark intercepts the traffic, but of course it is encrypted. So let's close the browser and try to intercept traffic generated by some applications. On the device, we already have installed the Facebook app. Let's clean the intercepted traffic and see what happens when we run the app. As we can see, since the application communicates through SSL, we can intercept only the encrypted traffic. As you can imagine, this isn't very helpful for our testing purposes, so we have to find a way to intercept the plain text of the communication, or even better, intercept and edit it on the fly. What we're going to do is to see how to configure the device and the host in order to forward all the traffic through a web proxy, such as Burp or OWASP ZAP. Doing this allows us to intercept the unencrypted traffic, analyze and edit it in the same way we usually do when we perform tests against web applications. To do this, we need to set a proxy server listening on our machine, and then set the proxy configurations on the device. If we want to intercept SSL traffic as well, we need to install the proxy certificate on our device. So let's see these steps one by one. First, we're going to use Burp as the proxy server. So let's start Burp, and then we'll move to the tab Proxy, and then go to the options. Here we have a list of the listeners for the proxy. So let's configure one listener in order to intercept all the requests and the responses going through our network interface. Let's select the listener and click on Edit. Here we can set 8080 as port and then select address 192.168.1.128 in the specific address field. Now let's go in the certificate options and verify that the option Generate CA Signed Per Host Certificates is selected. Now our proxy is configured properly, so we can click OK and move over to our virtual device. We have our proxy server, but now we have to configure the device to proxy all the traffic through it. To do this, let's open the settings, then select More in Wireless and Network Configuration, Mobile Network, Access Point Names, and then the access point available. As we can see here, we can set the proxy address and port. So let's set the address option to 192.168.1.151, the port to 8080, and then let's clear all the other default values. These are the same configuration options that we have set in Burp. Now the proxy configuration for both the machine and the device should be correct. Let's click back to confirm the changes and then go back into Burp. Be sure to have the intercept option set to on. Let's see what happens now when we try to browse the website page www.elearnsecurity.com. As we can see, while we try to navigate the browser, Burp intercepts something. Here we see Burp is intercepting the browser traffic, meaning that our proxy is working fine. From here, we can now choose to forward, drop, or edit every packet that is intercepted. Let's forward the request, and as we can see, the page starts loading on the device. Let's turn off the interception to forward all requests, and then let's turn it back on. The page we have just requested was working on HTTP, so let's see what happens when we try to navigate HTTPS pages. As we can see, a security warning appears on the device, warning us about a problem with the certificate. Here we can choose to go back, view the certificate that has been provided, or continue and accept the certificate. It seems that when we try to browse through HTTPS, the certificate that the proxy offers is not verified on the device, and then we get the warning. If we inspect the certificate, we can see that in the organization value, we have PortSwigger, which is the authority used by Burp Suite. What does it mean? It means that we will not be able to intercept HTTPS traffic unless we confirm this authority. So let's click continue and see what happens. As we can see, Burp now is able to intercept the traffic, so that seems to work. Let's forward the intercepted requests, but as we can see, the message appears again. This happens because the certificate was issued for www.google.com, but every time we request a page from a different domain, the warning is going to appear. This time, if we click on View Certificate, we can see that the common name is clients1.google.it. So if we want to continue browsing, we need to accept this certificate as well, and any other certificate for every different common name. As you can imagine, this is something that we want to avoid. Otherwise, we would have to accept hundreds of certificates every time. Since some applications work through SSL, they won't work with this configuration. If we try to open the Facebook application and reload the data, we can see a connectivity error message. Since applications don't usually allow us to accept an untrusted certificate, we are not able to use the application itself. The same thing happens for Evernote. Here, for example, we can see that Evernote fails to synchronize data. So now that we know that SSL traffic doesn't pass through our proxy unless we trust the Burp certificate, we have to find a way to bypass this. The best way to do this is to obtain the root certification authority certificate from Burp and install it on the device. This will allow the device to automatically trust every certificate provided by the root certification authority, which in our case is Burp. In other words, we will not need to accept each certificate anymore. So let's see how we can download the root CA certificate. Let's open Firefox and set the proxy options to work with Burp by opening Firefox Options, Advanced, Network, and then click on Settings. Here let's set the proxy option to Manual Proxy Configuration and configure the address and the port with the same value we used before. Now that Firefox has been set to use Burp as the proxy, let's navigate any HTTPS website. In the same way that we got the warning on the device, Firefox warns us about an untrusted certificate. Let's click on I understand the risk, then add the exception, get the certificate, and then view. Here we can see some information about the certificate. Let's move in the Details tab and select PortSwigger Certification Authority. With the root element selected, let's click Export and save the certificate onto our machine. Now that we have downloaded the certificate, let's close Firefox. Here we can see the certificate that we exported with Firefox. Now we need to install this certificate on the device so that every certificate issued by Burp will be automatically trusted. To do this, let's open a new console and use the ADB push command to store the certificate on the device. Before pushing the file, let's verify that the device is available by issuing the command ADB devices. So let's upload the certificate with the following command: adb push c:\users /els desktop portswiggerca.crt, and we'll put it in the /sd card/ file on the device. This error appears because ADB is not able to communicate with the device. To fix this, let's restart the ADB server by issuing the following commands: adb kill server, adb start server. Now we can try the previous command. As we can see, it works. Now the certificate is on the device, but we still need to install it. So let's go into the virtual device and click on Settings. Here, let's select Security and then Install from SD card. As we can see, it automatically identifies the certificate. Let's click OK to confirm and then insert the device PIN. If the PIN is not set, we need to create a PIN and then confirm it. So if everything has been set properly, we should now be able to intercept all the traffic, no matter if it is encrypted or not. Let's go back in Burp and set the intercept option to off, so we don't need to forward every request and response. Now let's go into the History tab and let's clean up all the previous requests and responses. Let's open Facebook and verify if it works and if Burp intercepts the traffic. As we can see, Burp intercepts some of the HTTPS traffic, but the warning on the application still appears. It's okay. Let's try to update the page and it will work. Here indeed, the message disappears. So the application successfully loads our profile data and Burp intercepts all the traffic, even if it is HTTPS traffic. Here indeed, we can see the plain text of the requests and the responses. Let's clean the history again and try to add a new post and see if it still works. Once again, we get a connectivity error. Let's just try to upload the post once again. And as we can see, it works. In Burp, we can see the request that we have sent and all of its data. Of course, this works for other applications as well. If we open Evernote, we can see that now it is able to synchronize all the notes. While Burp works fine sometimes, we get some connectivity errors with SSL communications. Using the same configurations on the device, let's see how to configure and use another great proxy tool, OWASP Zap. Zap works in the same way as Burp, but here it's slightly easier to export the root CA certificate. So let's start Zap and start configuring the proxy settings. Once it starts, let's click Tools and select Option. In the new window, let's select Local Proxy and set the same configuration used for Burp. So we're going to use 192.168.1.128 as the address and 8080 is the port. Since the device has already been configured with these settings, let's open the web browser and try to navigate to some pages. As usual, since we are requesting websites through HTTP, everything seems to work. So when we request HTTP www.elearnsecurity.com, we can see that Zap intercepts the requests and organizes them under the node sites. Here in the left pane, we can see all the sites requested, while on the right pane, we can inspect each request and response. We can inspect every request and response by selecting the item and then opening the tab on the right. So what happens when we try to access a site through HTTPS, or we start an application such as Facebook or Evernote? As we can see, if we try to load page https www.google.com, the security warning message appears. If we inspect the certificate, we can see that now the organization is Ferrand. So let's close the browser and try the Facebook application. Once again, Facebook displays an error message. So similar to Burp, we need to install the root certificate authority certificate for Zap Proxy. To do this with Zap, we can click Tool in the top menu and then select Options. Now in the available options, let's select Dynamic SSL Certificate. As we can see here, we have the certificate signature, while with the Generate button, we can generate a new certificate. If we click Generate, Zap warns us that a root CA certificate already exists, so let's click No and select the option Save. This allows us to save the root CA certificate directly from Zap, so we don't need to use Firefox or any other browser to save the certificate. So now that the certificate has been stored on our machine, we need to upload it on the device with the following command. We'll use ADB push C users ELS desktop the CA cert file, and again we'll place it on the SD card directory of the device. Now we can go back into our device and install the new certificate. Once again we go to Settings, Security, Install from SD card. So now the Zap certificate has been installed as well. Let's go back in Zap and clean all the site entries in the Sites tab. Now if everything works, we should be able to navigate through HTTPS without receiving any warning messages. As we can see in the device browser, the security warning doesn't appear anymore, and we can inspect the requests and responses in clear text. Let's try to search something and see if it still works. As we can see, the request has been intercepted and all of it is in clear text. Here, for example, if we inspect this note, we can see the plain text of the request. This configuration works for applications too. If we open Facebook, once again we can see that everything is working and that Zap is still intercepting the traffic. Let's verify that Evernote works as well. Here we see the application successfully synchronize the notes. If we inspect the Evernote note, we can see that it is HTTPS, but if we open the request, we can see the clear text that has been sent. Here, for example, we can see our username and password used by the application. So what we have seen in this video is how to sniff and intercept the traffic generated by virtual devices. We've seen how to configure Burp and Zap in order to intercept the clear text of all of the device communications. From this point on, we can use the device and the proxies in the same way we perform security tests against web applications. Thanks for joining us.